Hello everyone, this is Suresh from Azure ADB. Today our topic is how to compare your data frame schema. So mainly this is for doing schema validation. So to compare a data frame schema by using df.schema.fields against your expected schema. So if you pass your expected schema in the form of a dictionary and comparing this dictionary with your data frame schema. So we'll see with the example how we can do this. So initially I'm reading my CSV file. So this is in my catalog location and I mentioned inferSchema as true, and I'm reading this data frame and these are all the columns I have in this data frame. So columns and respective data types. So next what I'm doing is I'm writing schema validation script here. So that means I mentioned one variable here in form of a dictionary, in the form of a dictionary with key value pair. I mentioned all the columns, all the column names, their respective data type. So key value pair I mentioned here. So on top of that, what I did is I written this code. So first I given for loop. So here I mentioned for loop for field in df.schema.fields. So first we'll see what it gives df.schema.fields. So first, what is this df? That is whatever I read CSV file, that is a df. So from this df, it extracting the struct fields. So if you see example here, see df.schema.fields. So what we'll get is it gives a list of struct field objects, each representing column. So column, data type, and nullable type. So first understand what is a df.schema.fields in this code. So here in this for loop, df.schema.fields. So first we will understand what is it. So df.schema.fields, it will give you this result. So what it giving is struct field. Inside struct field, it giving. So for each struct field mentioned column name, data type, and null, whether it is true or false. So that means my df column has these many columns. So starting with start underscore date and ending with load underscore date time. So if you see here, this is start underscore date and it is ending with load underscore date time. And if you see this print schema, you will see their respective column date and date type. So since we mentioned inferSchema as true, by default, it detecting their data types and their is nullable or not. So one more option we can do is instead of inferSchema as true, we can define the schema. So while defining the schema, so that same format we are getting here. So if you want to define the schema, we'll get same as it is. So you can run this query df.schema.fields for that CSV file. You will get same result here. So next, what we need to understand is for loop. So for field in df.schema.fields. So if you iterate this whole thing, this list, what result we will get? See for field in df.schema.fields and I'm printing field. So this field I'm printing here. So that means since this is a list now, so it will iterate one by one. So first it will iterate one. So this one struct field, that whole thing will get here. And in second iteration, it will iterate this one and so on. So how many columns are there? That means how many struct fields are there? It will iterate those many things. So now we understand what is this for loop. So for field in df.schema.fields, and inside for loop, I am giving one condition. So expected underscore type equal to expected underscore schema. So expected underscore schema is this one. So this I defined, this schema I defined because I want to compare schema of this one and this CSV file, whether these both are same or not. This kind of validation. So here what I'm doing, expected underscore schema. Since this is a dictionary and it has key value pair, suppose I want to extract data type from this dictionary, what we'll do normally, we'll use get method. So dictionary, this dictionary dot get, and inside that we need to provide the key. Suppose I want to extract this particular data type, so I need to provide this key value here. So for getting that key value, I given field dot name. So from where we'll get this field dot name is, see while doing iteration, whatever this field is, so it will take here that for each iteration that respective field it will consider here. Suppose in case first iteration, so this is first iteration, this is the field. So in this, what it will do is, what I given is field dot name. So field dot name means from this it will extract column name. So field dot name means column name. Field dot data type means this one. Field dot nullable means this one. So if you want to understand more about this one, so I already made one video on df.schema.fields. From that, how to extract field.name, field.datatypes, field.nullable. So you can watch that video before coming to this. So now what will happen? From this iteration, from this first iteration, so it will extract this one, start underscore date. So if you see here, this is the expression we are talking about from that code. So expected underscore schema dot get field dot name. So if I try to do this one, no, this expression get field dot name, what I will get is, if I try to print this expected underscore type, I will get all data types from this expected underscore schema. See, expected underscore schema is a dictionary. By using get method, I am pulling all column names by using field.name. So if you see here in expected underscore schema, so all these data types, so string type, all these things we are getting there. Okay, so all these things we are getting there. So we'll see why we are getting none there. So further we'll see. So now this second line of code understood, no, from this. So now we understood this one. Now we understood up to here. So next, what I given is, I given if condition. So if expected underscore type, then what it has to do is, if field dot data type is equal to expected underscore type. So that means field dot data type. So from this field dot data type. So that means that field is which one? This one. So field dot data type means this one, date type. So this date type, so field dot data type is equal to expected underscore type. So this expected underscore type, from where we are getting this one, from this variable. If both are same, then we need to print whatever this field name, no, respective field name, that means column name, matches the expected type, that data type it will print here. If it is not matching, then it will come to else condition. It mentions that that particular column expected. So that means actual expected data type, and found what it found data type, it will print. So if expected type, this expected type, it is not matching, then directly it will come to else condition and it will print that extra column. This column is extra column. So now we'll see one by one. So first it printing start underscore date. Expected string type, but found date type. So that means it coming to this else condition. So here field name is column name, that is start underscore date. Expected is, here expected type is expected string type and found is date type. So we'll see why we are getting this. So here expected underscore schema dot get field dot name. So from our dictionary, that is this one, expected underscore schema is the dictionary dot get, and here we are getting column name. So field dot name means from here first we are getting start underscore date, in second one product underscore URL. So all these columns it will come here. So next expected underscore schema dot get dot get start underscore date. That means from this dictionary, it will pick value of this particular column. Okay, so why it will pick is, since we are getting get method. So get of start underscore date. Start underscore date is the column name. So that means in this first key value pair is this one. So I'm passing this key in get method. What I will get output is this value, I will get output there. So that means string type. So for this particular column, string type, it is there. So we are extracting string type. So I'll take screenshot of this. And I will come to this dictionary. So now if you see this, so first one we saw, and next we'll see second one. So get product underscore URL. See here for product underscore URL string type. And for category, this is integer type. And for a default group, see here default group, that is string type. So like this, for each and every key, it will extract value here. So only one difference you will find here, this one, because whatever this product ID is there, so we don't have in this dictionary. So we don't have that particular column in this dictionary. So since it is not there, what it does is it will print none. Okay, so that's why if you see here, we got none here. See here, we got none here because we don't have that particular column. So now we understood this one up to here. If you come to this one, if expected underscore type. So that means now what is the result of this expected underscore type is this one, string type. So if this string type then what will come here? If, that means if string type. So that means whether it is if expected type. Expected type, what we are getting result here is data types we are getting. So it will see any of the data type, means it getting data type or not, that it will check if expected type means. So for first condition, we have data type, then it will go to this if condition. So if string of field dot data type. So field dot data type means this one, this field. And if you see here, field dot data type, that is this one, date type. So that is date type. Next, what it does is field dot data type is now date type. So date type is equal to expected underscore type. So here, what is this expected underscore type is string type. So here string type is there, but actually date type is there. So that means it is not matching. So that's why here it mentioned is expected string type. So actually string type, expected type is string type, but we found date type. And similarly for second thing, here we have string type, but if you see here for product underscore URL, see for product underscore URL, here also string type is there. Product underscore URL string type is there. So here also string type is there, and here also string type is there. Okay, so since both are matching, it giving product underscore URL matches expected type string type. And if you go to category, if you see here category, here integer type is there. So what it's telling is if a field dot data type. So here field dot data type, what is there for category string type. But here integer type is there. So since both are not matching, no, so that's why it mentioned category. Expected is integer type, but found string type. So that means since this condition is not matching, it coming to else condition. So similar way, default underscore group. So if you check here for default underscore group, this is string type. And if you see here, string type. So since both are matching, so we'll get output as default underscore group matches expected type string type. And a similar way, source underscore target also, both are matching string type. Next, it come to cloud platform. We'll see cloud platform here. Here string type is there. And if you see here for cloud platform, integer type is there. So both are not matching. So what it gives output is expected is integer type, but found string type. Okay, so similar way, it will check each and every column. So this scenario we'll see product underscore ID. So here from our data set, we have product underscore ID column that is integer type. Data type is integer type, but whatever I defined here, expected underscore schema, we don't have product ID column. So that's why it telling that this is extra column, because in else condition I given. So if this particular column, it is not there in expected type, it has to print like extra column. Okay, so all possible scenarios we mentioned here. So one is expected string type, but found date type. Second condition is matches. Both the types matches in data frame and dictionary, both the types are matching. And the third condition is this one, extra column. Okay, so these are the three different cases we added here. So like this, you can compare the schema of your CSV file or you can say any input file with your own schema. So finally, this is your requirement. So this is the requirement for validating the schema. So you can compare this schema with your table schema, whether both are matching or not. If any mismatch is there, then it will print like this. Okay, so that's all about this video, how to do schema validation. So if you really like this video, please like and subscribe. Thank you.